Next presentation is Pete Mestemaker. He is our dealer representative for Trimble Geospatial. And Pete, if you're there.
Yeah, I'm here. Troy, can you hear me?
Yeah, we can hear you good. We can also see your PowerPoint there. Pete is going to be talking to us about a couple things. First of all, the new Trimble R980 GNSS receiver platform, probably the newest GNSS product offering from Trimble on the geospatial line. And then also about a new, well, maybe not so new, but maybe new to this area, the IBSS way to create corrections for rovers. So Pete, we're a little bit behind schedule. Right now, you probably still have about 30 to 35 minutes or so of time if you'd like to fill, but we're ready to go.
Okay, Troy, are you seeing my screen?
Yes, sir.
Okay, and I am in like PowerPoint mode, present mode.
I can actually see your screen as if the presentation is running, so it looks good.
Okay, good, thanks. So first of all, I want to say thanks to Monson. I always appreciate the opportunity to come do these presentations. This, by my count, should be my 8th year in a row of doing these. I'd also like to thank Monson for putting the added pressure on me of following Jonathan, right? So that is no small task from my end. Most importantly, though, we need to thank all of you end users that are out in the audience. I know that everybody out there is extremely busy, and just really appreciate you taking the time out of your schedules to spend this time with us. Okay, so we're going to talk about the R980 today. This is just kind of the evolution of Trimble's GNSS. I am typically, I'm typically not the type of person to put up a bunch of marketing jargon, but I do believe that the R980 is an advancement from the R12i. We will go ahead and we'll look at that. These are just some of the 5 key takeaways, right? So in the presentations that I have done previously, you will have heard me talk about ProPoint. Okay, that is the RTK engine that sits in the R980, and we'll dig into that a little bit more. But that RTK engine just continues to amaze, right? The places that we can take it, the environments that it allows us to work in, it's quite astonishing. Next, we'll talk about TIP, which is the Trimble Inertial Platform. Okay, so that's just the IMU-based tilted observations. Okay, and then move into some of the new things, right, that the R980 offers, right? So a dual-banded radio, a 4G modem, okay, and some flexible configuration options. All right, so here's just the agenda. We'll talk about those key technologies. Dive into the Trimble ecosystem a little bit. So that's kind of where we'll talk about Connect, IBSS, some things like that. We won't go super deep into those, but there are resources out there for everybody to explore those further. And then time for questions. So, I always like to run presentations. I think that questions are a little bit more meaningful if they're asked appropriately within the presentation. So Troy, Emily, if we do get questions through the chat, feel free to interrupt and let me know that we've got questions. Happy to answer those as we go along. And again, chances are if you've got the question, somebody else in the audience does too. So I think we can all get more out of these types of sessions if there's some interaction taking place. So again, if you've got questions, please don't hesitate. I'm sorry, Troy.
Yeah, absolutely, man. We'll send them over to you. We'll feed them to you as they come along.
Yes, and tell TC we can't see if he raises a hand.
Okay, so again, just moving into the key technologies, right? Here we're just kind of looking at a little bit of a timeline of this particular platform in Trimble GNSS, right? So this all started with the R10 back in 2012. The R10 ran at that point in time was the most creative, ingenious RTK engine called the HD GNSS engine, right? So it was the first type of engine that we had where you didn't have true hard flags for float and fixed or initialized, right? It was 100% a precision-based GNSS receiver, just meaning as it converged on a solution, we would set those tolerances in the survey style. And again, you didn't have the hard triggers of fixed and float, right? We didn't solve the integer ambiguities, things of that nature, right? It was a converging solution. Then in 2018, the R10-2 was released, and with that came the Maxwell 7. So the Maxwell 7 is the chipset that we use in all of our highest end receivers today. Okay, it is what enables ProPoint to be utilized in the way that we utilize it. Okay, 2019, you can see there the R12 was released. That was really the first mass release of ProPoint. Okay, and then a year later, we did the R12i, which was tilted observations. We could do tilted observations with the R10, but it was all magnetometer driven. It wasn't a very nice process, I guess I would say. And then that pushed us to where we were in 2024, right? With the R980. Okay, so let's look at some of the differences between the R12i and the R980. Biggest thing to me is the comms. Okay, so with the R12i, we had a 3-ish G modem. Something is not going to work real well in the developed countries on their current networks. Okay, the R12i also only had a 450 megahertz radio. Okay, also the memory. Now the memory I think is a little bit less beneficial. As we've moved along, right? I know when I first started the survey in 97, I used to do a lot of static work. That's really where we're utilizing the internal memory on these receivers. But we did bump that up from 6 gigs up to 9 gigs in the R980. Okay. Now, with the R980, we now have a 4G modem. Okay. So I know Troy talked about IBSS when he kind of did the introduction to this session. So that plays a big role when we talk about IBSS, and we'll dig into that a little bit more. It also has a dual banded radio. Okay, so we can do 450 or we can do 900. All right. One of the other things that we did last year, Jason's coming up after me, so he'll talk about corrections and services a little bit more. But we started to, with any new receiver that was sold, I think this was maybe April of last year, that you get a 1-year Centerpoint RTX subscription. Okay, so that's just us kind of dangling the carrot, because tying back into what Jonathan said, redundancy, right? RTX, exfil, another thing that we'll talk about here. Those are redundant solutions that are going to enable you to continue working in the way that you want to, right? And then one of the last things is just the way that you purchase your gear, right? So we've given you some options. So if we talk about ProPoint, right, again, that is the RTK engine. That is what fuels the R980. Okay, and again, that would not be possible if we didn't have the Maxwell 7. Okay, so the R10 ran the Maxwell 6, and that was just a completely different chipset, right, in the receiver. So I was back in testing in those days of 2012, and what would happen when we would load a ProPoint engine on an R10, and then we would monitor the CPU usage in that thing, is it was just maxed out, right? It was running at 90 to 100% all the time. The internal heat was going through the roof. We're all smart enough to know here what happens when we run a CPU and in that type of a setting, right? So it just, we're just going to burn it out. We're going to work it to death, right? It's going to be fried in 6 to 12 months. Okay. So without the Maxwell 7, we couldn't do ProPoint. We couldn't do TIP. some of the other things as well, right, that we'll talk about as far as IonoGuard, things like that. Again, we've already touched on the updated comms, that center point subscription that comes along, right? And we all know these receivers can stand up to basically any conditions out in the field. So as far as the updated comms go, the R980 again has a 4G LTE modem. Okay, it is not specific to any carriers, and it would be an end user supplied or a user supplied SIM card in there. Okay, and then we've also got the dual banded radio, so we can do 450, we can do 900. As I'm sure everybody on here knows, 450 is the traditional survey range that we would broadcast our corrections over. 900, at least on the Trimble side, has always been where we put it on heavy iron. Okay, so some of the benefits to that dual band, right? You have different benefits from each different range, right? With 450, we get the longest range possible. Okay, however, it comes with its limitations as well, right? So when I was surveying back in the field, I can remember working with, I think the company's name was Atlas out of Indianapolis, to help facilitate me getting an FCC license, right? Because the FCC views us as broadcasters, right? When we're broadcasting from our GNSS base station. So, so that's a limitation, right? That is, it costs us money, it costs us time. It imposes limitations because we're only licensed to transmit on certain frequencies. Once we go over to 900, that's a license-free spectrum as long as we broadcast at 1 watt or less. Okay, so again, it's great for small projects. And what does the dual band do? Well, it just gives us interoperability, right? It allows us to work on more sites with efficiency. So, I can speak to back in the day when I first joined sales, that was in 2017. Marty was the one, Marty out of Reno, would call me maybe once a month and say, hey, Pete, do we have any R10s with the 900 megahertz? So we used to make a version of the R10 that had a 900 megahertz radio in it. And, Marty and Jeff out there in Reno, I think it was probably tied to the mining industry, but, a lot of the times in those situations, they would have a permanent base station set up, right? So obviously we can cut down on human error, possible sources of error, right? If we can tie into the base station that they have. So same way with road construction projects, right? Long linear projects where they don't necessarily want, the guys running the heavy iron to be setting up a base station every day. So they'll go ahead and set up a permanent base station, move it along the project as they go. And again, if we as surveyors can tie into that to do what we need to do, whether it's staking out, whether it's as-builting, whatever the case may be, obviously the less setups we have to do, less chance of human error, right, creeping in there. Okay. So this is a question that I have had several times, right? With the R980 just coming out middle of last year, why did we not do a 5G modem? Okay. And I think the map here is probably the most telling, story behind that, right? If we would have done a 5G modem, we would have limited where that product could be sold. Okay. So again, the dark green in the map is the, places where 4 and 5G are prevalent. And then the lighter green is where 4G is available. So, we would not want to limit ourselves to that. The graphic, or the comment across the bottom right is telling as well, right, that 791 telecom operators, with 4G and LTE networks, right, in 240 countries. So again, that just ties directly into the map. But 5G is something that also brings a lot of complexity, right? So different types of antenna arrays, both in the hardware devices, you know, as well as how they transmit it right at the tower. So, you know, while it may be really prevalent in the US, as you can tell, you know, it is not so prevalent in other places around the world. So because the 980 is sold worldwide, obviously that's something that we would want to capture, right? So I think that's probably why we didn't go 5G. All right. So term configurations, right? This is something that we did not have with the R12i. As we know, the R980 is directly replacing the R12i. Okay. So term configurations, basically where, you know, traditionally you would always go and buy the hardware, buy the configuration that you wanted, or just we would have different SKUs of the hardware that would, you know, be a base station receiver, a rover receiver, or both. So now you've got the option, right, to you can purchase the hardware, you can purchase a configuration to load on that hardware, right? They would all be annual configurations, and you know, move forward if that's what you want to, right? It obviously, you know, from our perspective, it gives a lower entry point, right? For some people that maybe wouldn't get into a Trimble solution because of the price. You know, and again, termed configurations, right? Maybe some of you might think it's more applicable, you know, from a software perspective as opposed to on a hardware. I may agree with you on that, but either way, right? You now have the possibility to purchase how you want to, right? So those are available to you. These are the options that you have, right? Where you can buy a base rover config, or you can buy a rover only configuration, right? One thing we don't have is a base only configuration. So with both of those, you've got, excuse me, you've got all constellations available to you, all signals, okay? The IMU is activated, and you've also got exfil, okay? Now, you obviously don't have to move down that path, right? We also have perpetual configuration, so we don't want to force you into purchasing a certain way, right? You can purchase how you want to purchase. So as far as perpetual configurations go, you can see what we've got available here with, you know, with no limitations, right? You've got the base and rover, okay? All constellations, all signals, everything is active on the receiver. There is not an option that you can activate that doesn't come on the base and rover configuration, okay? If you're only interested in rover, you could do a rover, right? So all that simply means is that you cannot set it up as a base, right? You could not set it up to broadcast. You still have tilt, you still have exfil, okay? If you move over to a base station, well, if we're setting up a base station, we're not going to be taking tilted observations, right? Because we're setting up over a stationary point. It's going to be our base to broadcast our corrections for a single base solution. In that scenario, you don't have IMU and you don't have exfil, right? Because if that's the only functionality, the only way that you're using the receiver, then you know, you don't need those things. Okay. Now you can see down in the yellow box, those are options for you to upgrade, right? So if you do rover, you can add base. If you do a base configuration, you could add rover functionality, you could add IMU, you can add exfil. Okay. That also ties in with the light configurations that we have. So two of those, base and rover or just rover. And the only difference with those is that we don't enable the IMU and you don't have exfil. Okay, we'll talk about exfil a little bit more here in a bit. So just talking about ProPoint, you know, ProPoint again, boy, when I first started the survey back in '97, I was using a Trimble 4800 unit, and you know, there would be times I would cross my fingers that I could take it out, track enough satellites, wherever I was working, to get an initialization. You know, ProPoint is the way I describe ProPoint, again, not being an engineer that has worked on it, but throw everything at the kitchen sink at it and let ProPoint do its thing. Okay. Enable all constellations, enable all signals, throw everything at it, and let ProPoint decide what helps and what doesn't help. Okay. That is why we need the computational power that the Maxwell 7 chipset brings, right? Throw the kitchen sink at it and just let it go. Okay. Now, if we talk about tip, okay, that's another thing that requires a lot of computational power because, you know, we've got how many different sensors in here that enable this type of functionality. You know, there's quite a few, and they are updating at an extremely high rate in order to achieve the results that we achieve, right? But you know, again, this would not be capable without the Maxwell 7 chipset, right? So, you know, there are other manufacturers out there that obviously have this functionality. You know, it was funny. I was talking with a colleague. This was sometime last year, and he bought a piece of land down in just outside of Phoenix, and had a guy, local guy, come out to survey it for him. You know, not worried about the brand of receiver that he bought out, just knowing that it wasn't Trimble, but he did have you know, an IMU in there. And you know, if anybody's been down to you know, outside of Phoenix, right? If you're not along a waterway, it's a lot like you guys there in Utah. You know, if you're not along a waterway, you're in a pretty decent GNSS environment, right? It's not too challenging because the vegetation is pretty low. And this guy he was telling me this guy would go out, take a couple shots, and then he'd have to basically reinitialize or recalibrate his IMU, right? So, you know, that's one of the things with this is it works out of the box, right? You've got all the functionality in your hands, whether you want to use it, whether you don't want to use it. You know, I will tell you with a control point, you know, we automatically turn it off because what the IMU can do is over time it can drift. Okay. So the way that we keep it aligned is with movement. So I'm sure there are plenty of you out there that have an IMU based receiver. When you first start it up and it's sitting there on its bipod legs, it's going to tell you the IMU is not aligned, right? But as soon as you pick it up and you take, you know, 2 or 3 steps in any direction, that movement aligns the IMU with the GNSS, right? And once it's aligned, then we can go ahead and we can utilize it for data collection or for staking out, right? Staking out, it might be almost more useful than doing topo because again, wherever the tip is where we're computing the position, right? So, you know, one of the other things that we probably don't talk about enough is the integrity monitor. So, you know, for one, I've had these questions several times. You know, when do I need to recalibrate the IMU sensors in the, you know, the R12i, the R980? And the simple answer is if Trimble Access doesn't tell you that you need to, you don't need to. Okay. 2 main reasons that you would need to would be, you know, we're calling it inertial concussion here. It's basically a drop of the receiver, right? Where we can get the sensors out of whack, or if that receiver has gone through, you know, extreme temperature change, right, in a fairly short period of time. So those are the 2 main reasons. You know, other than that, and again, Trimble Access is going to let you know if you need to, right? So if Trimble Access doesn't tell you to, then don't do anything. All right. So we're going to keep moving on here. We're going to talk about IonoGuard. We'll talk about exfil. Some of these other things we won't necessarily explore too much. But there are resources out there for you, right, to explore these types of things. So, you know, IonoGuard is very fitting that we're talking about it right now. So, IonoGuard is something that is meant to mitigate the effects of solar activity or scintillation, right? So, as solar activity increases, right, as solar storms happen, you know, you kind of see this big burp or this big belch, right, in pictures of the sun. And as that happens, it's throwing a bunch of charged particles, you know, towards Earth, right? And as those charged particles hit Earth, a lot of them get trapped in the ionosphere. Okay, so my understanding of scintillation from talking with people that are a lot smarter than me is that you know, as the GNSS signals try to pass through the ionosphere, there is some attraction with these charged particles, right? And the more charged particles you get, the worse it's going to be, right? So, you know, that's what we're looking at here in these pictures, right? You know, we all saw the Northern Lights. Well, I didn't actually, but, you know, I've heard stories of people seeing the Northern Lights, you know, in places down here in the lower 48 where you don't, it is not usual, right? And that is, again, caused by this increase in solar activity. So IonoGuard is meant to mitigate the, you know, the negative effects that these solar storms have on our GNSS systems. Okay, so these storms, I'm sorry, not these storms, these solar cycles, right? They run on about an 11-year time frame. Okay, so and the one that we're in right now, ironically, is cycle 25, right? And it is going to peak in 2025. Now, previous modeling that they had done said that cycle 25 was going to be a little bit closer to 24, which, as you can see in the graphic here, 24 was not as intense, right, as we had in that would be what 22, 21. Cycle 21, 22 were very similar, maybe a slight decrease in 23. Okay, and then 24 was less drastic, right, than 23. They were predicting 24 again to be closer to 25, sorry, to be closer to cycle 24 previously. They've kind of redone those models, and now they're saying it's going to be closer to 23. So a little bit more intense, right? A little bit more disruptive to what we try to accomplish as surveyors using some of the sensors that we use, right? So IonoGuard is our attempt to mitigate those negative impacts of solar activity and enable you to keep working, right? That's the ultimate goal, right? Is to allow you to keep working, you know, during some of these peaks in the solar activity, right? High ionospheric effects. So what you're looking at here is I believe this came directly from Stuart Riley, who is one of our, he's probably the best guy that I know. And it's why he runs our GNSS division, but he's based out of Sunnyvale. We had a GNSS receiver placed up northern Canada. So, you know, you typically experience more negative effects from solar storms at the poles and around the equator. Okay, so where we're situated, I'm based in Colorado. You know, most of you in Utah or Nevada, right? We're not hit as badly as some others are, but you know, we can still get some negative effects. So what you're looking at here is a receiver that was up in northern Canada at a time of high activity, high solar storm activity. Okay, and this first graph, top is horizontal, bottom is vertical, and what we're looking at here is the effects that solar activity is having on that receiver without IonoGuard. Okay. And then if they turn on IonoGuard, you can see how that mitigates the effects, right? We are hovering much closer around zero without the drastic spikes. So, and again, I've talked with people up in Canada. I've talked to people down in South America. These are material results, material benefits that they are seeing, right? That allow them, again, to keep working when other people they're just kind of shut down. They're dead in the water, right? They can't keep going because they just simply cannot measure, right? And if they do, they can't trust their results. So IonoGuard is very real. And, this slide kind of made me laugh, right? Because again, I've told you, I started surveying back in 97 with the 4800 GPS only. I used to use the Trimble planing utility quite a bit, right? When can I go out? When can I actually survey, right? With that sensor. Because again, we were so limited with the constellation that we had. Nowadays people don't really use it that much because you don't have to, right? If you've got a GNSS receiver, you can track so many birds up in the sky that typically you don't have to be worried about how many satellites you're going to see. But you can now use the Trimble planing utility to see what type of ionospheric effects that you can have, right? So I actually pulled this graph this morning. So this is basically Denver today. The TEC stands for, what is that? Total electron content. So that is a measure of, how the charged particles in the ionosphere could affect us surveying with GNSS, right? And you can see at just a little bit after 6 o'clock tonight until maybe 10 o'clock, there is going to be some significant solar activity out there, right? That could be detrimental to how we want to survey. Okay. So again, it's better to know this going into the day as opposed to going out, driving 2 or 3 hours to where our job site is, and then maybe realizing that, right? So just so you know, it's out there, really super easy to use. I had not used it since, back in the days when I was actually surveying. And, I just updated the position, spit it out, just took that screenshot and threw it in here, right? So it is super easy. The way that we turn on and off IonoGuard, right, is simply through the web UI. Okay. And then you can see the receivers here that IonoGuard will work in. Okay. One of the important things to note is that IonoGuard, just like ProPoint, okay, ProPoint works best when we have a ProPoint base station and a ProPoint rover. Okay. Again, that all constellation, all signal thing that I've talked about, that's why it works best from a solution standpoint. IonoGuard is going to work the best when we have a IonoGuard base and an IonoGuard rover. Okay, because basically, again, my understanding what happens is those signals get slowed down as they pass through the ionosphere. Okay, and at the base station, we can kind of calculate what that offset is, right? And that offset gets transmitted from the base to the rover. Okay, so Sean will maybe talk about this a little bit later. I know that we are very, very eager to get IonoGuard implemented in VRS networks, right? Because a lot of people use them, especially there in Utah, right? You guys have great coverage. So, I know that we are eager, but currently, I believe it's really only on single base solutions. Okay. So we talked about this already, CenterPoint RTX. It's something that is included now. If you buy a new receiver, you get a year of CenterPoint RTX. Okay. So, again, kind of tying back to what Jonathan talked about, having some redundancy there. You may always survey with the VRS. All right. But what happens when you get into an area where you don't have cell coverage? Okay. Centerpoint RTX can kick in, or exfil, which we'll talk about next, can kick in and fill that gap for you. Okay. So Centerpoint RTX, and again, Jason will talk about this more. It's a PPP solution that we offer. And again, I might be a little bit biased, but I do think it's the best in the industry. Okay. Exfil is something else that comes with our premium receivers. Okay. Introduced back in 2012 with the R10. And what exfil does is it basically fills in some gaps for you. Okay. So, I always like to tell the stories of me back in the day surveying. I'm out of radio range. I cross the backside of a hill. I go down in a depression, whatever the case may be, I lose radio link, right? Well, if we lose radio link, we're kind of dead in the water. What exfil does, think of it as kind of timed RTX, okay? Exfil is going to work for you for 5 minutes after you lose your correction source, and it will fill in the gaps. Let you take those last few shots so that you don't have to get out your total station or move your base station setup, okay? And, again, it's on the receivers that we have today. You can see the little differences in the radio icons right here, okay? My guess is that you may use exfil and you may not ever even know that you do, okay? So right now, here's what our portfolio looks like. You've got the R980 sitting there furthest on the left, the R780-2, the 580, and the DA2. So all of those receivers are ProPoint receivers. The 580, the 780, and the 980 are the ones that have the Maxwell 7 chipset, right? So again, Maxwell 7 chipset is what allows some of these more advanced technologies to come into play, right? So now we'll talk about Trimble ecosystem a little bit. There will be some other folks on here later on today that will talk about this, like Luke, and I'm sure that Joe will talk about this as well. But Trimble Connect can be a game changer, okay? Trimble Connect is our cloud solution, and it can really tie the field and the office together, okay? It is also something that enables us to do IBSS, which stands for Internet Base Station Service. We'll dig into that a little bit more here. Here we're just talking about access, right? What you can do with access with these newer, higher functioning receivers, okay? Again, I'm not going to go into these for the sake of time right now, but we do have all sorts of things on YouTube regarding Trimble access that you can probably look up every one of these things, right? If you're interested, okay? Now, as far as IBSS goes, again, it stands for Internet Base Station Service. And basically what we're doing with IBSS is we are taking the radio out of the equation, okay? So if we have connectivity, internet connectivity at the base station, which again, this is why I think this ties in so well with the R980, because we could do IBSS with an R12i or an R12, okay? But what we would have to do we would have to have an access point to the internet at our base station, whether that be a hotspot, whether that be a controller with a SIM card in it that was left there, okay? Those are the types of things that I think really could entice people to, pique some interest in what that sensor is, what it is, what is it doing? And it's something that somebody may steal, right? With the R980 now, we can just put a SIM card right in the unit. We can start it up as a base station, set up a survey style where we're doing IBSS, okay? Connect comes into play here, all right? Because what we do is we pipe those corrections up to Connect, and then people on the rover end, you can have as many people as you want on the rover end. They can pull down those corrections, right? So it's the same as a UHF radio in that sense, but it comes with benefits, right? So for one, we don't have to set up a repeater, okay? We don't even have to set up a radio, right? So it can be savings from an equipment standpoint, from a time standpoint right there. A lot of you that have surveyed, again, when I first started, our channel spacing for our assigned 450 frequencies was 25 kilohertz. Okay. We are now down to 12.5 kilohertz. The FCC likely very soon is going to cut that down to 6.25 kilohertz. Okay. Every time that they do that, we are taking the pipe that we can send data through and we are cutting it in half. Okay. It's like setting up a repeater. Whenever you set up a repeater, you're setting up your time to broadcast. It goes from 1 second to a half second. Okay. However, we are sending more data than ever, right? Because we've got triple frequency receivers that are tracking all constellations. Okay. So if we can't bundle up all the information and transmit it in 1 second, we do what's called bandwidth limiting. Okay. And we basically start pulling information out, right? If we are pulling satellite information out of the base station, we can't use it at the rover. All right. We are then not taking full effect of ProPoint. Okay. So with IBSS, as long as we have internet connectivity at the base station, internet connectivity at the rover, and we can access Connect, which we can access Connect with either a subscription version of Access or Trimble Access perpetual license that is under a current warranty. Okay. Then we can do IBSS surveying, right? We don't have to worry about range anymore for the most part. We still have those ppm errors, right, that are compounding. So, if we think about 1 ppm, what does that mean? At 10 kilometers, we could be introducing a centimeter of error, right? You can go out and survey at 30K if you want to, but then you're taking that 1 centimeter of error and you're increasing it to 3, right? So again, just keep in mind what you are doing as far as that goes. But again, we're not tied to the limitations of a UHF radio, right? Which you have, there are significant limitations with a UHF radio, all right? So again, here just talking about Connect, Connect is a common data environment, right? It is there for collaboration, right? You will see, again, with some other presentations, how Connect is playing a more integral role in our workflows. Okay. We used to use Connect as basically the cloud component to do data transfer from the field to the office and back. All right. Joe, I'm sure we'll talk about something called Triceps, Trimble Reality Capture Platform Service, right? So it is a way to get all the interested parties with scan data together so that everybody can function on the same page, right? It is a super powerful tool that's in the toolbox that I don't think gets used to its full potential. Okay. So again, if you do not know about Trimble Connect, please reach out to Monson. Please talk to them about it. It can really, I think, change your world, right? It really can. It's really, really powerful. And as far as how we use it on the survey, on the geospatial side, it is only going to increase. Okay. The sooner you jump into it, the better, I would say. So this is just, again, talking about Trimble Connect again. These are all of the different types of products, softwares that we have where Connect just comes, right? You don't pay any extra for it. So if you have a subscription version of TBC, a subscription version of Trimble Access, it just comes with it. If you have a perpetual version of Trimble Access, but it's under warranty, it comes with it. If you have Sight Vision or TerraFlex or SketchUp, okay, you get Connect, right? Connect is vital for Sight Vision. It's how we feed models into Sight Vision so that we can view them out in the field, right? It is how we obtain data that we collect using the Sight Vision system. So as I said, Connect is present and it is just going to get more present as time goes on. This is just resources, right? Please feel free to go out to trimble.com. All sorts of resources on the R980 and other things that we've talked about. And sorry, Troy, I didn't save you much time here, but if we've got any questions, I'm happy to entertain those.